Welcome back. Today we're going to be looking at Unit 1, Day 3, Domain, Range, and Function Notation. The first part of the notes is all about vocabulary, so if you don't mind, pause the video and just copy what's on the screen. Okay, so a lot of these vocabulary words are just a review of Algebra 1. The first thing I want to go ahead and talk about is a relation. A relation is basically a relationship between two variables, and sometimes we can see this relationship by looking at a graph or a table. The domain is the set of all x values. So whenever you're listing the domain, make sure that you write the domain from small to big, and you don't have to write the numbers more than once if it repeats. For the range, it's the same idea as the domain. It is the set of all y values. So whenever we write the range, we write from small to big, and again, you don't have to write the numbers more than once if it repeats. Then lastly, let's talk about what a function is. A function is a relation where each input, which we denote as x, has exactly one unique output, which we denote as y. Now, when we learn about functions, it's kind of confusing, but we typically just say that, hey, if x values repeat, then it's not a function, which is absolutely true. So what this is trying to say here is that let's say you have an x value of 2 and it's paired with the y value 3. So your ordered pair is 2 comma 3, but if 2, that same x value, is mapped with another y value, let's say 7, then you have an ordered pair of 2 comma 7. Then that is going to break the uniqueness rule, right? 2 can only be paired with one y value. So if you have 2 comma 3 and 2 comma 7, the x values repeat, therefore it is not a function. If x values do not repeat, then it is a function. So I want to go ahead and take a moment and look at number 1. It says find the domain and range for each relation. So we have a graph with points. This is a discrete graph. So what I want to go ahead and do when it comes to this type of problem is label each point as an ordered pair. So for instance, if I'm looking at this first point here, then I will label this as -2 comma 4. And when we write ordered pairs, the x comes first and then the y comes after. So this is in the form x comma y. If I'm looking at this point over here, this will be 1 comma 1. And this one would be 4 comma 2. And this one would be 3 comma -3. And this one would be 4 comma -4. And lastly, we have -3 comma -1. So we're going to highlight every x value. So this is an x value, x value, x value, x value, x value, and x value. And this is our y. So we're going to go ahead and highlight all the y values. So let's go ahead and specify the domain, and then we will specify the range. Now remember, the domain is the set of all x values. So we're going to be listing all the x values that are explicitly shown on the graph. We're going to write the domain and range from small to big, and if there's repetition, well, we only need to write the number only once. So for the domain, we're going to say -3. So since we have a bunch of ordered pairs, what we need to do is draw in our squiggly bracket. Then we're going to list all the x values. So first thing is -3, because that's the smallest x value that we have on our graph. Then right after that is going to be -2, then 1, and then 3. And notice that we have 2 4s, right? So we only need to write 4 once. And then there we go. That's our domain. Now for the range, again, is the set of all y values. So the smallest number that I can see is this -4. So we're going to write squiggly bracket, -4, comma, -3, -1, 1, 2, and 4. And that is the range for number 1. Number 2, we're going to be finding the domain and range of this table dealing with average movie ticket prices. So we have the years and the prices listed out. Now, typically with time, that deals with X values, and then right after that will be our Y's. So we're going to go ahead and say, okay, the years deal with X's and the prices deal with Y's. So I can go ahead and create my ordered pair for each row. So the first row, we have the year 2000, and the average movie ticket price for that year is $5.39. So I can go ahead and write 2000, comma, $5.39, and we can do the same thing for each row. So this will be 2001, and then $5.65. And then this one will be 2002, comma, $5.80, and then 2003, comma, $6.03. So let's go ahead and list out our domain. Remember, the domain is the set of all X values. So I'm going to write my domain from least to greatest. So 2000, comma, 2001, comma, 2002, comma, 2003. And then the range is the set of all Y values. So we have $5.39, $5.65, $5.80, and lastly, $6.03. Now, the next portion of our notes, we're going to determine if a relation is a function. To determine if a relation is a function, you have to check to see if each input has exactly one output. So in other words, if X values do not repeat, it is a function. If X values do repeat, it is not a function. So let's take a look at number 3. We have this table. This table is the same table as the one that we saw in number 2. So we have the years and the prices. Remember that years deal with time, and time is X. So the years are our X values, and the prices are our Y values. So we have the year 2000, 2001, 2002, and 2003. I don't see a repeated X value here, so I can go ahead and say that this is a function. And the best reasoning is each X has one Y. All right, we have math test scores. Here are the names and the scores. Now, the names are going to be our X values, and then the scores are going to be our Y values. So again, the names are X's and the scores are Y's. So we have Jan, Helen, Luke, Soren. Assuming that there isn't another Jan, Helen, Luke, and Soren in the class, we can go ahead and say that this is a function because no names are repeated. So each person has one test score. It would be weird for Helen to have a score of 90 and 88 on the same math test. That would be bad, and that wouldn't be a function if that was the case. So number 5, comparing car models to car colors. Would that be a function? Well, let me go ahead and just take a moment to give you an example. Let's say you have a Camry, and it's black. And then there's another Camry, and it's white. Well, we know that the car model is our X value, and the colors are the Y values. So we have Camry black and Camry white. So this is our X, this is our Y, and this is our X, and this is our Y. So the X values repeat So therefore, it's not a function. Okay, so now what we're going to do is we're going to tell if a graph is a function by using something called the vertical line test. Now, a vertical line looks like this. If a vertical line touches the graph more than once, then it is not a function. However, if it touches the graph only once, then it is a function. So let's take a look at number 6 here. We're going to use the vertical line test to determine whether each relation is a function. So what I'm going to do is I'm going to draw a vertical line through this graph here. And as you can see, it does touch the graph more than once. It touches here and there. So therefore, this is not a function because it fails the vertical line test. Number 7. So for this one's a little odd, but I'm going to draw a bunch of vertical lines to demonstrate my point. So I'll draw one here, here, there, and also there. So based on what you're seeing right now, it doesn't fail the vertical line test, but there's one more place that I didn't draw a vertical line through. And you probably guessed it, it's this one right here, or this section right here. So it does touch the point here and also there, but this one's a little weird because I'm going to explain why. Now, as you can see, it goes through this shaded dot and then towards this open dot. Now, you have to understand the whole idea of shaded dot versus unshaded. Remember, the shaded dot is basically where that point is included, whereas the unshaded dot is not. So really, this vertical line in blue is only touching one place, but the other that's unshaded, it actually just goes through it no problem because there's actually no X and Y as part of the domain and range, if that makes sense. So really what I'm trying to say is this part is included. Since it's shaded, it goes through that one, but since this is unshaded, you can treat this point invisible. So therefore, this is a function. I'm going to say yes for this one. It does pass the vertical line test. Now, number 8, you can go ahead and use the vertical line test to see if this is a function or not. So let me go ahead and draw a vertical line here, 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 and then let's go ahead and draw a vertical line through these 2 points. Now you can see that this does not pass the vertical line test because it touches or intersects the graph more than once, right? So no, this is not a function. All right, let's move on to this. You will often see functions written in function notation. This generally makes functions easier to evaluate. So what we have here is this. We have y equals f of x. Now, f of x is short for the function of x. And we generally just say that f of x is the same thing as our y. So whenever we input something, we're going to get an output, okay? So if I were to, let's say, I'm going to give you an example. If I said y is equal to 2x, and I said if x is equal to -3, well then, what is y? So again, if you're given something like y equals 2x, and if x is equal to -3, then tell me what the value of y is. So all I need to do here is replace this x with -3. So y equals 2 times -3 is -6, and then I can go ahead and create my ordered pair. We said that the input, or our x value, is -3, then our output, or our y value, is -6. Okay? But what if I give you something like this? F of x is equal to 2 times x, and I'm going to ask you, what is f of x if x is equal to -3? Now, it's the same idea. We said that f of x is the same as y. So if f of x is equal to 2x, and I'm asking that x is equal to -3, then what is f of x? So all I have to do is replace these x's with -3. So I have f of -3 equals 2 times -3, and that's going to give me -6. So f of -3 is -6. If I put this as an ordered pair, your answer is going to be -3, comma, -6. Again, just like what we did when we had y equals 2x. All right, so now, in function notation, the variable x is generally used to represent the domain or independent variable or input, and f of x is generally used to represent the range or dependent variable or output. All right, so number 9 says f of x is equal to 3x minus 4. I'm being asked what f of -2 is. Now, as you can see, f of -2 is the same thing as f of x, right? So the x value in this case is -2. That's going to be my input. So I'm going to replace each x value with -2. So I have f of -2 equals 3 times -2 minus 4. And 3 times -2 is -6 minus 4. It's -10. So that's the output in this case. So again, our input is -2, and then our output is -10, and that is our answer. All right, so let's take a look at f of 4. So remember, this is in the form f of x. So then I'm going to replace each x value with the number 4. So I have 3 times 4 minus 4. So 12 minus 4, therefore it's 8. So your answer, as an ordered pair, by the way, is 4, 8. Now let's take a look at the last portion of number 9. It says, what is x when f of x is equal to 14? So we know that f of x is 14, and we're using this equation here. So how do I find the value of x when f of x is 14? All I have to do here is this. I'm going to replace f of x with this number and then solve for x. So I have 14 equals 3x minus 4. And again, the goal here is to solve for x. So I'm going to have to get 3x by itself. So if I add both sides by 4 here, this is what I get. I get 18 equals 3x. And then this is where I need to divide both sides by 3 here. So 18 divided by 3 is 6. And that is going to give you your x value. So how do I write this as an ordered pair? Well, we know that our x is 6. What is the y? Well, remember, f of x is the same thing as y. And that's already given to you. It's 14. So your answer is 6, 14. Number 10, we have a different function this time. So we have f of x is equal to 3x squared minus x plus 2. We're being asked what f of 0 is. So the input is 0. So I'm going to replace each x value with 0. So we have f of 0 equals 3 times 0, quantity squared, minus 0 plus 2. And notice we have 0 squared, which is just 0. So you're dealing with 3 times 0 minus 0 plus 2. And look at that. 3 times 0 is 0. 0 minus 0 is 0. So we're basically left with positive 2. So your input is 0. Your output is 2. So we can go ahead and write 0, 2 as our ordered pair. So the next thing that we're going to do is figure out what f of -1 is. So again, all I got to do is replace each x value with that input. So I have f of -1 is equal to 3 times -1 quantity squared minus -1. So I have the minus sign, and then I'm replacing the x value here with -1, and I'm putting parentheses around -1, plus 2. So now I got to use my order of operations here. So I have -1 the quantity squared, which is -1 times -1. That's positive 1. So I have 3 times 1 minus -1, that's +1 plus 2. So now I have what? I have 3 plus 1 plus 2, and that gives you 6. So therefore, our input is -1, and our output is 6. So as an ordered pair, you have -1, comma, +6. Now 11, we have a graph this time. Now remember, with an x and y plane, you have a bunch of points in the form x comma y. So if you have your x, you can look at your graph and figure out what y is. Now let's take a look at f of -1. So remember that this is f of x. The x in this case is -1. So all I need to do on my graph is figure out, okay, where is -1 located on the x-axis of my graph, which is right here. Now, this is the game of inputs and outputs. So if your input is -1, then what is the y value that is paired up with that -1? So if I know that this here is -1 on the x-axis, then what's it paired with in terms of y? It would be this y value here, 1. Okay, so at this point, this is in the form -1 comma 1. The input is -1, the output is 1, so therefore the answer is 1. Now we're going to do the same thing with f of 1. The input is 1. 1 is located right here on the graph in terms of the x-axis, and then we can figure out what the y value is associated with that. So that would be 5, right? So f of 1 is 5. Now we have 12 here. It says f of -3. So if the input is -3, -3 is located right here on my graph. Well, the y value would be +1. Now the next question here is, what is x when f of x is equal to 4? So basically, let me rewrite this question so it makes sense. If y is 4, remember that y and f of x are the same thing. If y is 4, then what is x? So let's take a look where 4 is on the y-axis. So here is 4 on the y-axis, and we have our function literally right here. So then all I need to do is drop down and see what the x value is. So if this is 0 and this is 1, this must be 2. So the x value, the input, is 2. So x equals 2. Let's take a look at number 13. We have f of -2. The input is -2. The input is always our x value. So if I look on the graph here, -2 is located right here. So the function looks like this, and we have a point right here. So if x is -2, then what is the y value? The y value in this case is 0. And then our last problem for today. If y is -5, then what is the x value? So if I look, I can see that this is -2, -3, -4, and -5. So this is where -5 is located. So what is the associated x value? That would be, if I draw a line above this time to reach the x-axis, that would be at 0. So this point here is 0, -5. And this is our x value. So x equals 0.